Welcome to video 1 for this unit on linear relationships. In this video, we're going to focus on representing proportional relationships. Graphing is a way to help us make sense of relationships. But the graph of a line on a coordinate axis without scales or labels isn't very helpful. For example, say two water tanks are filled at different constant rates. The relationship between time in minutes, T, and volume in liters, V, of tank A is given by V equals 2.2 T. For tank B, the relationship is V equals 2.75 T. These equations tell us that tank A is being filled at a constant rate of 2.2 liters per minute and tank B is being filled at a constant rate of 2.75 liters per minute. At what time will the two tanks have 110 liters of water? Here are the graphs of these relationships, but without labels we can't even tell which line is tank A and which is tank B without studying them closely. Let's add some labels and scale to the axes and the two lines. While we now have more information, if we want to use the graphs to answer the question, at what time will the two tanks have 110 liters of water, then using an axis scale from 0 to 10 for time and volume isn't very helpful. If we use a vertical scale that goes to 140 liters, a bit beyond the 110 we are looking for, and a horizontal scale that goes to 100 minutes, we get a much more useful set of axes for answering our question. Now we can see that the two tanks will reach 110 liters 10 minutes apart. Tank B after 40 minutes of filling and tank A after 50 minutes of filling. It is important to note that both of these graphs are correct, but one uses a range of values that helps answer the question. In order to always pick a helpful scale, we should consider the situation and the questions asked about it. Proportional relationships can be represented multiple ways. Which representation we choose depends on the purpose. And when we create representations, we can choose helpful values by paying attention to the context. For example, a stew recipe calls for 3 carrots for every 2 potatoes. One way to represent this is using an equation. If there are P potatoes and C carrots, then C equals 3/2 P. Suppose we want to make a large batch of this recipe for a family gathering, using 150 potatoes. To find the number of carrots, we could just use the equation C equals 3/2 times 150, which means C equals 225 carrots. Now suppose the recipe is used in a restaurant that makes the stew in large batches of different sizes, depending on how busy a day it is, using up to 300 potatoes at a time. Then we might make a graph to show how many carrots are needed for different amounts of potatoes. We set up a pair of coordinate axes with a scale from 0 to 350 along the horizontal axis and 0 to 500 on the vertical axis, because 450 equals 3/2 times 300, and we create the axes to go a bit beyond the points we are interested in. Then we can read how many carrots are needed for any number of potatoes up to 300. Or, if the recipe is used in a food factory that produces very large quantities and the potatoes come in bags of 150, we might just make a table of values showing the number of carats needed for different multiples of 150. No matter the representation or the scale used, the constant of proportionality, 3/2, is evident in each. In the equation, it is the number we multiply p by. In the graph, it is the slope. And in the table, it is the number we multiply values in the left column to get numbers in the right column. We can think of the constant of proportionality as a rate of change of c with respect to p. The rate of change in a proportional relationship is the amount the output changes when the input increases by 1. The rate of change in a proportional relationship is also the slope of its graph. In this case, the rate of change is 3/2 carats per potato. When two proportional relationships are represented in different ways, we compare them by finding a common piece of information. For example, Claire's earnings are represented by the equation y equals 14.5x, where y is her earnings in dollars for working x hours. Jada's earnings are shown in this table. Who is paid at a higher rate per hour? How much more does that person have after 20 hours? In Claire's equation, we see that the rate of change, how many dollars she earns every hour, is 14.5. We can calculate Jada's rate of change by dividing a value in the earnings column by the value in the same row in the time worked column. Using the last row, the rate of change for Jada is 13.25. Since 490.25 divided by 37 equals 13.25. An equation representing Jada's earnings is y equals 13.25x. This means she earns $13.25 per hour. So, Claire is paid at a higher rate than Jada. Claire earns $1.25 more per hour than Jada. After 20 hours of work, she earns $25 more than Jada because 20 times 1.25 equals 25. Thank you for watching video 1 of 4 for this unit on linear relationships.